right? So the first one we said that for precaution, an example could be, what is that? Right. So ensure that the subject is not exhausted, right? You want to ensure that the person is fit for the experiment, right? You don't want them falling. If they're exhausted, then they will fall and hurt themselves. Also, think about
They
one
are.
more. I have one more
It,
in mind. Think about it.
why a link to ensure that the subject is not exhaust around completely different precaution.
It close to it, right?
So um
Is ensure the
exhaust.
safety of the subject and that the experiment goes as smoothly as possible with little errors as possible.
Oh wow. Oh no, that makes no sense.
What about the steps? Think about the steps.
Oh, we make sure so them never wait, make sure so them dry, sir.
Exactly. So make sure that the steps are dry. That's a good
And
one, right?
I'll clear your all objects.
Yeah. So you have between a couple to choose from, right? You have a couple to choose from. So remember, you only need one. All right.
Yes.
So ensure the steps. Ensure the steps are dry.
And and as we said, sir, we ensure say they not strip or nothing, sir.
All right.
We know we never we never encourage them to run up the steps, sir, because
Exactly.
that trip, the more vulnerable to trip
Right.
and then hurt themselves. Sir.
Yeah. That's a good one as well. All right.
Yeah.
So if anybody want precautions, they should go to Mr. Blake. Mr. Blake, you are up to help them. All
All right,
right.
sir. Yes.
Now the calculations we said to calculate the you want to show the calculations when doing your table, putting the table together. Show how you calculated work. All you need is to show one example, and you get your 5 marks. Right, relevant formulas present and calculations performed correctly. You get 5 marks. So that's 10 marks, and of course include your stuff for limitations, source of error, precautions. All right. So are we good on power?
Yes, sir.
Yes,
Yeah, we see
sir.
that the labs are not so hard. They're very easy, right?
Yes, sir.
Yes, sir.
All right. Now power. Lab 6 to prove the principle of movement. All right, and make sure you have your conclusion. So the conclusion for lab 5 power should to determine the power developed when climbing a flight of stairs. You will say that the power, right, of object A is so forth, and the power is object B, and this was of course done by um by allowing the person to climb the stairs. All right. And of course, in a discussion, you want to include these as well. What is the effect does mass have on power? When the mass changes, right? When you have a larger mass, right? One of these will be larger because we use two different subjects, we use two different persons. What about the power for the bigger person, right? I am seeing here that um well, it's a little tricky. All right, so I am seeing here for Mr. Blake that the mass with 47 kilograms, right? They ran up the stairs in 2.30 seconds. And for object B, right? I'm seeing that the person with 70 kilograms, they took a longer time. They took 5.91 seconds, right? So the bigger person was a little slower, right?
Yes,
Yes,
which was me.
All right, so you want to so yeah, you want to make note of these, and then the power, the final calculation for power I saw where the smaller person that took a shorter time, they exerted more power because they run up the step faster. So they run up in one they had a power of 143 watts, while
What
the
power?
object B subject B had a smaller power. They exerted less power because they went up the step in a large amount of time, right? Which would be 81. So they had a power of 81. So you can compare the power based on the amount of time that the person took and also with the mass as well.
So is
Right.
oh, because me did confuse because subject B would have more weight, them exert more force because to maintain the body, but he weights or mass
Right.
go up that more difficult than subject A.
Right.
Is why
They would exert more power.
that subject A would have,
But if you look at it, remember that the object A ran while object B walked.
there.
Right? So we see a little difference right there. But because if they were moving at the same velocity or they were climbing the steps with the same speed, then object B would have exerted more power because that person is heavier than object A. But
Yes,
the
sir.
fact is that they
In a
took
disc,
they run. So you can discuss these things in your experiment. All right, in a discussion, it will give it more. It will give it more to think about.
yes, sir.
All right. Now, lab 6, I believe. Lab 6 is moment of a force. Let's go through this one. Of course, let's go straight to our mark scheme, right? The procedure, all steps should be performed correctly, or stated correctly. You recorded what was observed. So as I said, you can include this in your discussion, or you can have a separate thing called observation, right? So essentially, you want to, what did you observe for your lab as it relates to the moments lab? What did you
You know,
observe?
most of me never did do the one I eat that, sir.
Or you can
I
think
just
about it. You can use your results, right?
alright, so
For the table, let me see if I have a table here.
wait, let me see about the diagram.
All right.
So we did put why go again?
All right. So we put a heavier one on this side. We should make some changes for this one as well. Let me just go back to this. We're almost through. We're at lab 6. We're almost done. All right. Where is it?
Yeah.
This. And open this. No. Lab experiments. Lab manual. Right. Here we go. And go back there and open. Okay. Good. Go down now to moments. Right. So we made some changes. Mr. Aldrich, could you tell me what changes I made for that method?
The meter rule was placed at a paper.
All right. So of course, past tense. What else?
For it's 1.5.
All right. So this place 2 weights. Which one? 2 or 3?
2, sir.
2. So 1.5 instead of 1.
No, instead of 0.5.
Oh, okay. 1.5 instead of 0.5. All right. And what else?
And for 3, Instead of 10 centimeters, 5 centimeters.
5 centimeters. All right, good. And what else?
And for one Newton is 1.5. 1.5.
One, I just
In the same one.
this one. Okay. 1.5 newtons. Let me change it as well. 1.5 newtons to 5 centimeters from the pivot and adjust the weight. So is that it? Any more corrections?
No, sir.
All right, so take a picture of this and send it in the group for me. All right. So ensure that you have this in past tense, then you can get your full 3 marks. Very easy 3 marks. I give away 3 marks every lab. I don't know why. I keep on giving away 3 marks. All right, so for the table, the second part is recorded what was observed. Now, this is a little different than the last one. Now, this takes into consideration your table, right? So I split this up into 2 marks. 2 marks into 2. 1 mark, I put it towards the table, ensure that you have your title, ensure that you have your units, and you place in the right things here, and your table is enclosed, as always, right? And then I said precautions in performing experiment. You want to ensure that you have 1 precaution, as well as the others. Limitations, source of errors, and limitations, source of error, and precautions. Right? Now this, I split this up as well. I put 2 marks towards your table again, and then 1 mark towards your discussion, right? Given, no, yeah, 1 mark towards your table. So in all, 2 marks here. The table is 2 marks. Table is 2 marks. 1 goes here, 1 from here, and 1 from here. That is 2 marks for your table. While for your discussion, you should state what you observed about the moments lab. All right, so report results and give proper explanation, right? This is 2 marks going towards your discussion or your observation. Yeah, 2 marks towards the discussion and 1 mark for your observation. All right, is that clear?
Yes, sir.
All right, now, in your, what did you observe for that particular lab? We had our setup here. We had the clamp stand, right? And we had a piece of string, tying a ruler here. All right, it was a very interesting lab. Now we had 1 heavier over here. We had a heavier 5 newtons over here, 1.5 newtons over here, and we had 1 over here. Now, where should we put the 1 newtons for it to be balanced? In or out? We should put it towards the center or away from the center for it to be balanced.
Repeat, sir. Repeat.
Where should you put the 1? This is 1.5 newtons, and this is 1 newtons, right? So where should we put the 1 newtons in order for the system to be balanced?
Closer to the center.
No.
Wait. What will I do? Yes, sir. Move a little bit to the right, sir.
All right, so you should put it towards the right in order for it to be balanced. So that's what you essentially would state in your observation, that in order to balance the system, right, if you have a larger weight, right, you would place the larger weight towards the center, and if you have a smaller weight, you would place it away from the center in order for it to get balanced. That would be your observation for your lab. Is that clear?
Yes, sir.
Yes, sir.
Yeah, so if you have a smaller weight and you want to balance it with a larger weight, you would place it away from the center in order for it to get balanced, so that they would provide the same magnitude of moments. or a similar magnitude of moments. That's how the system is going to go in equilibrium. That is basically 3 marks right there, just by saying that. And of course, you have to go ahead and answer some of these questions as well. State the principle of moments. What happens to the beam if one force is greater and at the same distance, right? You could answer these as well. All right, answer as much of these questions as possible in order to get a full 3 marks for your discussion and explanation.
All right.
All right, of course, you will have your conclusions, right? Conclusion is 1 mark. And if you complete all of these, there's nothing stopping me from giving a full mark. And of course, you should place in your limitation, source of errors, and precautions, 1 of each, and your conclusion. All right, so this lab is very simple as well. No graph required here. All right. Yes, sir. No, sir. You understand?
Yes, sir.
All right. Now, moving on to the next lab. What's the next lab again?
Let me look.
Let me see.
What? Oh,
Was energy conservation, right?
Did you do that?
Mm-hmm. We did quite a lot of labs, right? So you should get those results, all right?
Energy conservation. Oh, never the last one then.
All right, so you should try and get these labs, all right? This is lab 7. All right.
Wait. We did today we do it?
No, not today. When you drop the ball or you drop the mass from the 2nd floor
Oh, yes, sir.
and we nearly bust Tyrese head, right?
This
I
the
don't know.
record.
All right. I don't know why you would throw down the 100 grams on Tyrese instead of releasing it. All right. Anyways, moving on. So, of course, you see any corrections for this, Mr. Aldre?
No, that's the past tense, sir.
All right, just the past tense. All right, that's good. And for title of this, of course, you should have your title here. Come on, you're giving away marks, right? You're giving away marks if you don't have a title and you're not. See there, right? So I also split this as well. So you should have your procedure. I also split this again the same way. It's the same type of mark scheme. One of these goes towards one of the record what was observed goes towards your table, and then one of this goes towards your table as well. All right, and two of these marks goes towards your explanation, and then one of this mark goes towards observation. So you want to state what was observed, and then observe in your results, and then you want to explain what is happening. All right. This is a breakdown of the marks. Going back up, ensure that you fill out your table properly here. Fill out the table. Also, you want to try and answer some of these questions. The same procedure for all the labs. Now, you will go ahead and calculate. For the calculations, I am suggesting, let me see. Right, the calculation is very easy. I will explain the calculations now. Now, Mr. Aldre, tell me what you have for your mass.
So what has to be done.
All right, so 0.1. What do you have for your height?
73 centimeters.
73 centimeters. And what you have for
Andre,
the
just link
one?
Repeat that, sir.
What you have for one?
1.25.
1.25. What you have for two?
1.0.
1.0.
Let's basically one.
All right. And what you have for three?
1.26.
1 point what?
26.
1.26. And what you have for your average?
1.193.
1.193. All right. So we would go ahead.
Not you, sir.
Okay. All right. So in order for us to calculate, this is a potential energy, right?
Yes, sir.
Now calculate the potential energy. It is mass times acceleration due to gravity times height. We'll change this height to meters, right?
Yes, sir.
What would we get?
Give me a second.
Centimeters to meters, you divide by 100, right?
Yes, sir.
So centimeters, it would be
0.73.
0.73 meters. 0.73 meters. Now, what is the mass of our object again?
Mass 0.01.
0.1
Yeah, 0.1.
times what is the acceleration due to gravity?
9. 9.8, sir.
Yeah, 9.8, but let us round that up to 10. Yeah, we usually use 10 unless a question states specifically use 9.8. We usually use 10.
Yes, sir.
No, and what is our height in meters?
0.73.
0.73. Now, what do we get here?
7.3. Wait, sir. Zero point 0.73.
All right, I was waiting for you to say that because these two cancel out each other, right?
Yes, sir.
0.73. Now, what is the unit for energy?
J.
Joules, right? Yeah, we haven't done this in class, but we'll give it some time. Hopefully, we'll do this next year or so. We'll be able to do this in class. So this is your potential energy. Now we'll go ahead and calculate kinetic energy. That's what we'll do now. Now, in order for us to calculate the kinetic energy, right, you will need your velocity. So kinetic energy is half mv squared. In order for us to find the velocity, we'd use this equation here. V is equal to U plus AT. Now, we want to find the final velocity. U is our initial velocity.
Yeah.
Right.
There.
Initial velocity. Now, what is our initial velocity of the mass when we dropped it? What was the initial velocity of the mass when we dropped it? When we held it out, what was the initial velocity before we dropped it?
No.
Right? So 0, right?
Oh, wow.
Yeah, just 0. It was at rest. And what is our acceleration? Give me a guess.
You have to do with time or force.
7.
No. Right?
What do you
All
mean?
right, that's a good try. This is the acceleration due to gravity.
Huh?
Right, acceleration due to gravity.
Yeah.
G, right? So G will be our acceleration and time. Now to calculate V, it would be G. What is the value of G again?
No joule.
No.
No.
G.
Gram.
Gravity, right? Gravity.
Me not looking.
G is gravity, right?
Mass time gravity dynamite. That's how you go.
All right, so it'll be 10.
Yes, sir.
Let me fix this.
What did I calculate? Yeah, X acceleration.
We're calculating now the kinetic energy. We calculated the potential energy as 0.3 joules, 0.73 joules. Now we're calculating the kinetic energy. And this is 10 times our time. What is our time? 0.193. All right, what do we get? All right, so Nigel says 11.93. He's correct, right? And this is in meters per second. So this was the velocity of the object just before it hits the ground. Right? This is the velocity of the object just before it hits the ground. This is the velocity of the object. All right? 11.93 meters per second. Now we'll go ahead now and calculate our kinetic energy using the velocity that we just calculated. Now, what is the mass of our object again?
0.
0 point, right here. 0.1, right?
Yeah, which part? Yes, sir.
The mass of the object is 0.1 times 11.93 squared. Right, I hope this calculates out to be, let me see, is that one calculate?
Let
me see here.
The kinetic energy.
Yeah, that's what we're calculating now. What do we get?
So in order to find the kinetic energy, you have to find out acceleration, right?
The acceleration is we using gravity as acceleration.
Gravity.
Right.
Alright, sir.
Acceleration due to gravity.
Yes, sir. And then I use the formula to calculate gravity.
Right, we know gravity already. Gravity is 10.
10, yes, sir. Then I use the MGH formula.
Right, that's the potential energy. So essentially we haven't done this in class as yet, as I said. But it goes from potential energy to kinetic energy. It is conserved.
Yes, sir.
All right. Let me see. 11.
Okay, yeah.
Multiplied by 0.1. What do we get for that?
Yes, sir. Nigel, I must say.
Sir, me get 0.60. 0.60.
You get 0.60?
Yes.
Mm.
Square that, sir?
Yeah, squared.
Oh.
What you get now?
7.11.
7.11.
So, but what?
So I will look over this again, but from this, is the kinetic energy the same as the potential energy?
Yes, sir.
Are you sure?
Yes, sir.
No, they're not. This is 0.73 and this is 7.11. 7.11.
You were lying.
So they're not equal. So the aim of this experiment was to determine if the energy is conserved as a mass falls from a height. And since they're not the same, right?
Oh, so then don't conserve.
So the energy is not necessarily conserved from this experiment. So therefore there could be errors. All right. We know that energy is conserved, but we might have done some error in calculation. But for now, they are not conserved.
Yeah.
All right. So you make a note of that. All right. You understand?
Kinda.
All right. So step 6 says we must calculate the gravitational potential energy, which we did up here, and then calculate the kinetic energy, which we did here, and we got 7.11.
So the one penny, the calculation them penny left. You have something to do. Yes.
Yeah,
no.
that is the velocity. We need the velocity to calculate the kinetic energy. All right.
Yeah, the same as acceleration.
The acceleration is g because the object is just falling. All right.
Yes, sir.
Acceleration due to gravity.
Yes, sir.
All right. So is this clear?
Yes, sir.
Yes.
All right. So we have 5, 6 more minutes left. Let's see if we can just finish the last one. You take a picture of this already?
Yes, sir.
All right. Let
No.
me go ahead quickly.
Yes, man. Yeah.
You gonna be here?
All right. Take a picture now. We take a picture.
Yes, sir. Yes, sir.
All right. Let me take this off and clear. Send it in the group as well. I will look over it again to see if I made a mistake in calculation or whatever, because it should be essentially the same. Let's do the last one now. The last one. Let's see if we can do that in less than 5 minutes. Hopefully. I don't know. I don't think that's possible, but let's try. Let me see here. Where is it? Oh, before November 8th. So we did this lab on November 8th. Share screen. All right, so let's skip the procedure because we know how we do that already. Ensure that it is in past tense. And we should have a title for that already. Now, the important thing that we want to discuss here is the mark scheme. No, this is an analysis and interpretation lab, right? This is the first one that you're ever doing. So pay attention to lab 8. Lab 8 is the most important lab right now because you're only going to do 3 of these. You're only going to do 3 lab 8s. You're not doing any more than 3 lab 8. This is 3. This is one of 3. All right. So pay attention to this one. Snell's law. All right. This was with the block. All right. Now you should. I'm wondering if I. All right. Let me see. Yeah. So Snell's law. You should ensure that your procedure, of course, report the results, and then, of course, have your graph. All right. So what will your graph look like? Must plot a graph of sine I against sine R. What would be on your y-axis?
Yo.
what would be on your y-axis? Sine I or sine R?
I.
All right, so sine I would be on your y-axis, right? And then you would go ahead and plot your graph. Now, you must determine the gradient of the graph. Determine the gradient of the graph, and then that would give you a particular quantity. All right. Now, very important is that you get the gradient of the graph, and then you state the relationship between S sine I and sine R, if it is directly proportional or inversely proportional. All right, do you remember how to calculate the gradient of the graph?
Yes, sir.
All right. Let me see here. Gradient is equal to y2 minus y1 over x2 minus x1. So this is how you really go ahead and you calculate the gradient. All right. And of course, have your limitation, source of error, and conclusions ready. Report the results. This would go to your table. Your graph, the gradient of the graph. Of course, you need a graph to get your 3 marks here. And you must state the relationship between sine R in your discussion and have the other components ready. All right, are we clear on this? All right, so we have less than a minute. I will try and mark some of the labs that I have for Mr. Blake, and I think Turner, I have some labs for Turner as well. I will try and mark them and send them by pictures. All right, so try your best, do your best, everyone, and remember that it is due on the 18th.
I am not familiar with this one.
You're not familiar with it?
But yes,
All right. Watch some videos on YouTube about it, all right? To get a better understanding.
Manual.
Is not in the manual as well?
No, sir.
All right.
Screenshot.
All right, I will do that.